Hello everyone. In this video, I'm going to go over the homework on t-tests. So this is an Excel homework, and I have 4 tabs, 1 tab per each problem. So they're just called number 1, 2, 3, and 4. And I have the problems typed into these text boxes. The procedure table for the t-test procedure is over here in column N. So I'll make some reference to that. And then I have places for you to type your answers down here for all of the steps. Okay, so let's look at the first problem. Anthropologists are still trying to unravel the mystery of the origins of the Etruscan Empire, a highly advanced Italic civilization formed around the 8th century BC in central Italy. They want to determine whether the Etruscans were native to the Italian peninsula, or, as many aspects of their civilization suggest, if they migrated from the east by land or sea. The maximum head breadth in millimeters of 70 randomly selected modern Italian male skulls and 84 randomly selected preserved Etruscan male skulls were found to help researchers decide whether the Etruscans were native to Italy. So these are some skull sizes over here. We're going to see if the Etruscan skulls are similar to Italian skulls. So here is our question. Do the data provide enough evidence to conclude that modern Italian men have smaller skulls than ancient Etruscan men? Okay, so that is what we were trying to conclude. That will be our alternative hypothesis. All right, so I've just broken down the steps from the procedure table over here, and I've just put them into these questions down here to give you an easy way to answer everything. So first of all, are the assumptions of the two-mean t-test satisfied? Make a box plot to check. If yes, just say yes. If not, explain why not. Okay, so the assumptions that we need to check are over here in our procedure table. So we need random samples, and I believe it did say random, right? I thought I saw the words random. Randomly selected. Yeah, and randomly selected. I'm not sure how realistic it is to really say randomly. Well, okay, if they say amongst the preserved ones, I mean, obviously you can't randomly select from the original Etruscan male population. It would only be the ones whose skulls somehow made it to researchers. Okay, but it does say random in the problem, so we'll go with that. And then our second part here, so we need to look at the sample sizes, and we can see the sample sizes from the length of these columns here. One of them is 70 because there's a label in the first cell, and then this one is 84. Okay, so those are quite large, but we still need to check that there's no extreme outliers. So to check for outliers, we can use a box plot. So just select both of these columns, A and B, insert, and it's going to be near the histogram. It's on the histogram dropdown under box and whisker. Okay, so I am seeing some outliers here. Let me put this maybe over here. I am seeing some outliers, but they don't look too extreme, I think. They're pretty nearby. They're within like a whisker length of the end of the whisker. For extreme, I would think like more than a whisker length away, or maybe even more than the whole width of the entire box plot away would be what I would think is extreme. So these don't look too extreme to me. I think they're fine. Okay, so then I'm just going to say yes. The assumptions are met. Okay, now for the alternative hypothesis. I want you guys to practice doing it in words and in symbols. So I explicitly put here places for you to do both of those. So this comes from the research question. Is there enough evidence to conclude that whatever comes after the word to conclude that, the rest of the sentence, that is the alternative hypothesis? Okay, so you can just copy paste the words right there. All right, let me do match destination formatting, so this will be green still. Okay, so that is the alternative hypothesis. Modern Italian men have smaller skulls than ancient Etruscan men. So which of these symbols is this going to be? Is it one mean smaller than the other, or is it just that the means are different? So you can see right here the word smaller. Any word like smaller, less than, or you can say it the opposite way, like larger or greater than. That's going to be this first one here. Okay, so that is going to put us into the one-tailed test. All right, so one-tailed test. I probably should have put an extra question in here to make sure you guys knew how many tails you're doing, 1 or 2. Okay, so I just said leave one of these and delete the other, so I'll delete that one. And I'm just going to make a note to myself here This is one-tailed test. Maybe I'll left align it. Okay, because I do need that information for doing the p-value later. It's one of the 4 arguments that you put into the Excel formula. Okay, now I gotta check, do the sample means match the alternative hypothesis? And I can check that by looking at the box plots. So what I mean is, here's my alternative hypothesis. Modern Italian men have smaller skulls than ancient Etruscan men. I gotta check that that's actually what this data is showing, that the modern Italian skulls in the sample are smaller, because if not, then there's no hope of using any statistical tests to try to conclude that. And Excel will actually give me an invalid p-value, but it won't warn me, so I have to know myself that it's invalid. Okay, so you guys can see when you hover over the X right there, you might have to zoom in a little bit to do this, like, because the median and the X's are like right, almost on the exact same spot. You hover right on the center of the X. If you hover over this line here, it's showing you 132. That is the median line right there. Right over the X, center of the X, 132.4428.571. I can tell that's the mean because only means have lots of repeating decimals like that. Okay, and it tells me that this is the Italian series on the little pop-up. Okay, and that is smaller than this number over here for the Etruscans. Another way you could get the mean is if you just select the whole column here for the Italians, it displays the average down here in this little box right down here. So the Italians is 132 and the Etruscans is 143. So I can see that my sample data does match what I'm trying to conclude, which is that the Italians have smaller skulls. Okay, so this is a yes. All right, now the null hypothesis just in symbols is fine. So it's going to be the opposite of the one that you put for the alternative hypothesis. So it's that one. Now, which population type do we have? Refer to the procedure chart and enter 1, 2, or 3. So this is for the 4th argument to the t.test formula in Excel. And this is the 3 types here. One is for paired data. That is when you're using one sample and you took 2 different variables from each member of the sample. That is not what happened here. We don't have 2 skulls for each person. We only have 1 skull for each person, okay. 2 is for when the 2 populations have the same standard deviation. I don't know why you would ever know that. That seems really strange to me. Like, why would 2 different populations ever have the same standard deviation? It should always be off by like at least a little bit. And then 3 is for when the 2 populations have different standard deviations, or for when you're not sure. We're always going to use 3 in this class. I think there might be like 1 person that has paired data for their project, but most of the time, 99% of the time, we're going to use 3. Okay, so this is type 3. And Excel has some fancy name for this, like heterostatic or something like that. Okay, now we're going to do the actual t-test. So equals t.test. Okay, and then you see your tooltip here after you open the parentheses, array 1, that's your first column. So you can just click on that A at the top and it puts in A:A for you for the whole column A. Don't worry, it'll ignore the text at the top of that column. Don't worry about it. And then comma, and then our second data column B, comma, and now you see the new tooltip that you get when you're on tails is either 1 or 2. So enter 1 for one-tailed, comma, and then this is the population type. So we are doing type 3, which is called, oh, I misremembered what it was called. It's called what is that? Heteroscedastic? I recommend you guys try working this word into your daily speech. Wow, isn't this lasagna heteroscedastic? Okay, anyway, so that's number 3. All right, so this is how your arguments should look to your formula here, AA, BB, 1, 3. And I'm going to hit enter. Okay, so now you got a number that has a letter in it. That is scientific notation. So this means 7.65306 times 10 to the negative 24, which is a very small number because 10 to the negative 24 means 1 over 1,000,000, 24 zeros. Okay, so if you convert this to regular number form, and then you move include more decimal places, let's see. Yeah, so the number of zeros right here should be like 23 zeros, because we would have to move this 24 places to get it right in front of this decimal place here. All right, so this is an extremely small number, so we're definitely going to do the interpretation that is for small p-values. Okay, so here's the interpretation for when p is very small. Just copy this sentence and fill in the blanks. With a p-value of, put your p-value, there is, I would say, extremely strong evidence to conclude that, and then we're just going to copy paste that part of the sentence that was the alternative hypothesis. Okay, so with a p-value of, maybe I'll put this back in scientific form just because it's shorter, so I'll say 7.65 times 10 to the negative 24. I'm going to write it like that. There is extremely strong evidence to conclude that, and now I'm just going to just come up here and just going to copy this, copy down here, go to the end of the part I wrote. Oh, it's not letting me paste. Hold on. Let me pull it from this. Control C, back down here. Control V. Oh, that's weird that it won't let you do the whole cell into there. Okay, so with a p-value of 7.65 times 10 to the negative 24, there is extremely strong evidence to conclude that modern Italian men have smaller skulls than ancient Etruscan men. Okay, so I don't know how convincing that is actually that they couldn't be descended from the Etruscans. I'm not sure how quickly people's skull sizes can change. I mean, evidently they can change over time because we all came from the same people originally, like in Africa, you know, before we went north and into Europe. But I'm not sure how fast they're able to change over the centuries. So kind of didn't really answer the question for me here. I wanted to know if the Italians were descended from the Etruscans or not, but I think I still don't know. Okay, well, anyway, let's go to number 2. So problem number 2, we're doing some golf equipment testing. So a golf equipment testing facility compared the difference in the performance of golf balls hit off a regular 2 3/4 inch wooden tee to those hit off a 3-inch Stinger brand golf tee. The same driver club was used for the test, and a robot swung the club. So if a robot swung the club, I'm guessing this data should be normally distributed. Pretty much anytime you're doing something that you're trying to do it exactly the same every time, but there's just some little differences because of random fluctuations, that'll almost certainly give you normal data. Okay, anyway, here's our research question. Do the data provide enough evidence to conclude that the mean distance is different for the 2 different types of tee? Okay, so we don't have a larger or a smaller, we just have different. So I can already tell this is the two-tailed test. But let's go through the steps one by one. Okay, are the assumptions of the 2 mean t-test satisfied? Make a box plot to check. Right, so first, before we do the box plot part, which is for assumption B, I need to check assumption A. What is my population that I am trying to sample here from? So I guess the population is robot swung the club. You know, it really doesn't. I guess my population, like theoretically, I would assume is every swing that you could have taken at the golf tee, or every swing that the robot could have taken at the tee. So I guess there's some randomness involved with, like, you're trying to do it exactly the same way every time, but there will just naturally be some randomness, like in fluctuations of electricity within the robot, and like air current fluctuations might throw off the swing a little bit, that kind of thing. Oh wow, this is a hard one. Is that considered a random sample if the robot did it, like, how many times did they do this? 30 times in a row? I think I'm so kind of uncertain about this that I think this might be one where I just have to leave it in my interpretation statement. Like, if you consider this random, then this is the interpretation. I'm really uncertain about this. Okay, let's look at our second assumption and see if that one is met. So for sample sizes 30 and up. I think we're at exactly 30 because both of these are in row 31 and there's an extra row at the top that we don't count. Okay, so let me look at if there's any outliers here. Let's see how that looks. Yeah, so there's no outliers, so that is fine. I think I'm gonna say maybe the assumptions are met, kind of depending on, I guess, what the people thought the population was. Unclear, somewhat unclear if the sample is random. Sample is random since we have a robot repeatedly swinging. The sample size and outliers are fine. Okay, I guess I'll just mention that in my conclusion, like this conclusion is valid as long as this is random enough for you. Yeah, I don't know. I mean, isn't it also possible that like maybe the robot did all of the regular ones first and then it warmed up a little bit and then that made all of the stinger ones different? I don't know. Did I give you guys some instructions for what to do if we don't meet the assumptions? No, I didn't tell you what to do. Yeah, so I guess let's just go through the rest of it and then we'll just mention this in the interpretation. Okay, that's enough waffling from me. All right, so for the alternative hypothesis, this is just going to come from the question. Do the data provide enough evidence to conclude that? And then what's after the word that is the alternative hypothesis. So the mean distance is different for the two types of t. Yeah. Boom. Okay, and then so different means unequal. So we're going to delete this one, and that means we are doing, this is a two-tailed test. Okay. Do the sample means match the alternative hypothesis? Check your box plot. So to match the alternative hypothesis, I mean, I just need to check that they're not exactly the same. Just like that's what my hypothesis says, that they're different. It would be really shocking if any two averages of two different sets of number were the same. So I assume they're probably different. I'm going to check using the average down here. 227.2 for that one. And 240.9. Yeah, so they're different. Did I make a box plot? Where'd my box plot go? Maybe I deleted my box plot. Oh well. Lost my box plot. Okay, whatever. Yes, they are not equal. Okay, so null hypothesis is going to be the opposite of my alternative, so it's that they are equal. Okay, which population type? It's still not paired data, so we're just, as usual, doing number 3. And now for my p-value, equals t.test. Okay, column A, comma, column B, comma, now the number of tails, so I'm going to put 2, comma, and which type is type 3, close parentheses, hit enter. Okay, this is an extremely small p-value. It's even smaller than the Etruscans versus the Italians. So unless this robot was doing something really funky, this should be evidence in favor of rejecting the null hypothesis and accepting the alternative hypothesis. So the interpretation here I'm going to do is for when p is very small, and I'm just going to include a note at the end about, you know, if you consider this to be random sampling. Or maybe I'll put that at the beginning. So if the procedure with the robot testing is considered a random sampling, it's questionable, then there is extremely strong evidence, I would say. Just do this in 2 lines to conclude that. And now I'm just going to paste my alternative hypothesis here. The mean distance is different for the 2 types of t's. Okay, I think that's the best I can do. Now let's do number 3. Okay, wow, we have really different sample sizes here. So this one's size 31 and this one is size 10. So we might have to do 2 different checks for the different sample sizes on these assumptions. But let's read this problem. An intervention program designed by the Stockholm Transit District was implemented to improve the work conditions of the city's bus drivers. Improvements were evaluated by G. Evans et al., who collected physiological and psychological data for bus drivers who drove on the improved routes intervention and for drivers who were assigned the normal routes, the control. Their findings were published in an article. Columns A and B are the heart rates in beats per minute of the intervention and the control drivers. Assume that the distribution of heart rates was normal for each population. I'm really curious what this intervention was. Like, did they provide them calming music, or like, did they give them more breaks or something? And I also think this is such a funny problem because I don't know if you guys have ever lived in a city and had to ride the bus anywhere, but bus drivers are like extraordinarily angry people. So, in my experience. So yeah. All right. Anyway, so let's check our assumptions. Were these random samples? Let's see. You know what? I don't think these were random samples. So we're going to have to mention that in our interpretation statement. Maybe on like a quiz or a test, I might tell you to just stop if the assumptions are not met. But here, I think I'll just, since I didn't tell you what to do, I'll just put that in the interpretation statement. Yeah, because it definitely does not say that it was random. Okay, so does not say random. Okay, now what about the other assumption, which is about normal distribution of sample means? So for small sample sizes smaller than 15, population data needs to be approximately normally distributed. Well, do I have any information about that? No, I really don't. And this is really too small of a sample size to tell just from, I think, looking at a histogram. A histogram is just going to not have enough columns to really show you much. I would say this is a situation where you should not do the t-test. Also, we can't tell if the data was normally distributed. So I guess if you see this question on a quiz or a test and I haven't clearly told you whether to stop or not, then keep going. But I think for this homework, I'm going to say let's just not do this one because this is really ill-advised to do a t-test when we have no idea if this data meets the requirements for this to be a valid result. Okay, so I'm going to not do this one. All right, on to number 4. Okay, problem number 4. The American Association of University Professors, AAUP, conducts salary studies of college professors and publishes its findings in AAUP Annual Report on the Economic Status of the Profession. The salaries of 35 randomly selected professors at public universities and 30 randomly selected professors at private universities are shown. And I'm guessing these are in thousands because otherwise this doesn't make sense. So these are in thousands, I guess. Is there enough evidence to conclude that professors at public and private universities have a different average salary? So I already can tell from the word different rather than less or greater that this is going to be the two-tailed test. But let's go ahead and go through the steps. So I did see the word random, which is great. I'm happy about that. Okay, so random samples and oh, actually, I just need to say yes if it's true, right? So the other thing I need to check then is sample size. Okay, column B has 30 entries, it looks like, and column A has 35. Okay, so we're in the large sample category, and that means any distribution is okay as long as no extreme outliers. So I'm going to put in the box plot. And I don't see any outliers at all. All right, so we are good to go for assumptions. Yay. I hate it when the assumptions are not met. Okay, so that's a yes. All right, now the alternative hypothesis. So I'm going to copy paste from the question. Professors at public and private universities have a different average salary. That is the alternative hypothesis. Okay, and now in symbols, because it's the word different, that's going to be not equal. So I'll delete this one, which means I'm going to also delete that one down there. Okay, do the sample means match the alternative hypothesis? And this is telling me I can check the box plot. So on the box plot, the two means are the x's, and I can see that they are different. Oops. They're in different heights. So this is a yes. Okay. Which population type are we doing? So it's not even the same sample size, so it's impossible for this to be paired data. And then, as I've said a million times, we're going to do population 3 because I don't know why any two populations would ever have the same standard deviation. Seems nonsensical to me. Maybe one of you guys can take a research methods class and tell me, when do you actually use that number 2? Okay, and next is the p-value. So t dot test, open parentheses, column A, comma, column B, comma, number of tails. This is 2 tails because we're doing the not equal kind. All right, and this is type number 3. Close parentheses, hit enter. Ooh, it's not that low, but I think this is probably low enough. So 1.88%. Yeah, it depends on what field you're doing this test in as to whether you would consider this result significant or not. Significant enough to reject the null hypothesis. I think this is low enough. So I'm going to go with the second interpretation, or sorry, the first interpretation for very small. Oh, they were all very small this time, weren't they? I don't know if I like that. Okay, with a p-value of 0.0188, there is, I guess I'll say, maybe I'll just leave it blank and just say some. There is evidence, or some evidence, to conclude that, and now I'm going to put the alternative hypothesis. So up here, there's evidence to conclude that professors at public and private universities have different average salary. Okay, that is it for this homework. I'll make it more clear on the quiz whether you should continue or not continue if you find that the assumptions are not met. Most likely I would either tell you like it's met for one of these problems but not the other, you figure out which one, or I would tell you to keep going and mention it in your conclusion, or I would clearly tell you to stop if I want you to stop. All right, hope this all made sense to you. If not, you'll have to send me an email or come to office hours, and I will see you in class.